In this video, we're going to be taking a look at Lesson 7.1, Ratios, Rates, Tables, and Graphs, and you'll need your Go Math book out, your math journal, and a pencil. So let's take a look at the essential question on page 173 or Go Math book, so you'll need to turn there. It says, how can you represent real-world problems involving ratios and rates with tables and graphs? So that's what we're going to be looking at today. So let's look at the Explore activity number 1 on page 173, and you can work with me as I work through these problems. Work with me in your Go Math book, that is. So let's take a look at 173, finding ratios from tables. It says students in Mr. Webster's science classes are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. The table shows the amount of distilled water needed for various amounts of ammonia. So we can see, first of all, we know that there's 250 milliliters for every 5 milliliters. Okay, so we can see what's going on. So for every 5 milliliters of ammonia, it's multiplied by 50 for distilled water. So from there we can see 2 multiplied by 50 will be 100, 3 multiplied by 50 would be 150, 3.5 multiplied by 50 would be 175. Then we think about what happens to 200. What number is multiplied by 50 to get to 200, and that would be 4. Okay, so we can fill out our table there. And it says in letter A, use the numbers in the first column of the table to write a ratio of distilled water to ammonia. So we could see this ratio would be distilled water will be the top. Ammonia would be 2 for the bottom there. All right, so how much distilled water used for 1 milliliter of ammonia? What we can do is divide both top and bottom by 2. You can see that gives us a unit rate of 50 to 1. Okay, so we could write in 50 milliliters here. All right, now it says use your answer to write another ratio of distilled water to ammonia. And we can see we're going to use our answer 50 milliliters. So we can see 50 to 1, okay, for our ratio. Now we can see the ratios in A and B, we can see are equivalent. And why is that? We know that the ratio 100 to 2 and 50 to 1, we can see we divided both 100 and 2 divided by 2 gives us 50 to 1. So we divided both top and bottom number there of our ratio. So that's how we know that they would be equivalent. Now let's take a look at letter D. It says, how can you use your answers to be to find the amount of distilled water to add to a given amount of ammonia? And what we can see here is we can multiply the amount of ammonia by 50 to 1, or by 50 would be a way to find the amount of distilled water to add to a given amount of ammonia. So we're going to complete the table where the equivalent ratios are shown in the table. So we can see 100 to 2 is equivalent to 150 to 3. And we know that because the initial unit rate is 50 to 1. So you added 50 to 100 and 1 to the 3 there. So 50 to the distilled water and 1 milliliter to ammonia. Now, for the next one, this is going to be 175 to 3.5. So this is not a full 50 to 1 ratio. This is a 25 to a half there. So we added 25 milliliters to distilled water and just a half a milliliter for ammonia. Now for the next one, we can see 200. It'll be 200 to 4. So add another 25 and another half, making it 200 to 4. Now, each of these ratios can be reduced down to 50 to 1 for the unit rate. Alright, so let's take a look at the reflect part. It says look for a pattern. When the amount of ammonia increases by 1 milliliter, the amount of distilled water increases by how much? So we can see ammonia 1 milliliter, distilled water 50, half a milliliter 25. So we can see even from 3 to 4, so 1 milliliter of ammonia, 150 to 200 would be 50 milliliters. So we can see increases by 50. That we can see the pattern there. So we know that 6 milliliters of ammonia requires, and what we could do is multiply 6 times 50 is going to require 300 milliliters of distilled water. So now we're going to be taking a look at graphing ratios, and we're going to use the problem on page 173 for the information on 174. It says, complete the table from the Explore Activity 1 that shows the amount of ammonia in distilled water. So we know the ratio is 50 to 1. So we can just complete this table, and I want you to do this with me. Alright, so now we have our table, and it says write the information in the table as ordered pairs. Use the amount of ammonia as the x coordinates and the amount of distilled water as the y coordinates. So we can see 2, 100, and let's do this together, 3 and 150, 3.5 and 175, and then also 4, 200, 5, and 250. So from here, what we're going to do is graph the ordered pairs, and it says because fractions and decimals can represent amounts of chemicals, so we're going to connect the points. So we know that we have, first of all, 2 to 100, so 2 and then 100 here. Let's graph that. We'll plot that point right there on our graph. The next one, 3 and 150, so we go 3, and then we can see between there is 150, and now we have 3.5 to 175, so we go between the 3 and the 4, and then 175 would be between the 200 and 150 line. So we'll graph that point, and then we can go 4 to 200, so we have 4 all the way to 200 now. I know mine's not exactly perfect, a little tricky doing it on here. And then we have 5 to 250. That's already graphed for us. And then from here we can see we'll have a straight line going all the way across, and we'll have an arrow. Kind of hid the different points there, but you should be able to see that on your computer, or on your book, I should say. If you have plotted all your points correctly, it should just be a straight line with an arrow going out. Alright, then what we could see section, it says graph the ordered pairs, so we've done that. And what it says to do is describe your graph, so we know that this is a line graph. Okay, so it's a line graph. Now let's take a look at letter C. It says for each ordered pair that you graphed, write the ratio of the y coordinate to the x coordinate. So since they're asking from y to x, we start with distilled water, and then we have ammonia. So y to x, we can see is 100 to 2. Let's write this together. We also have 150 to 3. We have 175 to 3.5. We have 200 to 4. And we have 250 to 5. Alright, for letter D. The ratio of distilled water to ammonia, as we have seen, is 50 to 1. Okay, for every 50 milliliters of distilled water, we have 1 milliliter of ammonia. Alright, so for letter the C section here, it says the ratio of distilled water to ammonia is 50 to 1. How are the ratios related to this ratio? Okay, for this we could say they are equivalent. And let's write that out. So they are equivalent. They could all be reduced down to 50-to-1 for the unit rate. Now it says for letter E, the point 2.5, 125 is on the graph but not in the table. The ratio of the y-coordinate to the x-coordinate here, we could see since it's 2.5 and 125, so the y to the x-coordinate, so we know 125 is the y-coordinate. We can see 125 to 2.5. Now we can answer the question, how is this ratio related to ratios C and D? And we could see they're related to C and D, once again, because they are equivalent. Because if we were to reduce this down to a unit rate, it would also be 50-to-1 as well. Okay, so we could write, same thing we did for letter D. I won't write it in here, but you can write the same thing. I just don't have any room. They are equivalent. All right, so we can see 2.5 milliliters of ammonia requires 125, as we can see right here, 125 milliliters of distilled water. Now, let's take a look at letter F. What do you think is true for every point on the graph? So we can see here what's true. The y-coordinate is the correct amount of water for the amount of the ammonia given by the x-coordinate. So it's important to make sure the ratios are 50-to-1, and that would be correct there. Now let's take a look at number 2. It says, how can you use the graph to find the amount of distilled water used for 4.5 milliliters of ammonia? So taking a look at that graph, I want you to think about that. And here is a possible answer that you may have. It says find the point on the graph whose x-coordinate is 4.5, so we would do that. We would find 4.5 between the 4 and the 5. The y-coordinate of that point is the milliliters of distilled water. Okay, so that's how you could find the answer to that for the reflect question number 2. Okay, so what I would like you to do is turn your Go Math books to page 175, and I want you to go through example 1, read through the A and B section, and when you are finished reading through that, I want you to complete the Your Turn. It says a shower uses 12 gallons of water in 3 minutes, and complete the table and graph below. So you'll need to take a look at that. 12 gallons of water in 3 minutes, and that'll help you complete the graph, and then you can also graph the data as well on the coordinate grid. So read through this and then work on number 3. You can work on that now. Okay, so you can see the table that I have filled out. 2 to 8, 3 to 4, 3.5 to 14, 5 to 20, and 6.5 to 26. I did not graph on the grid. It's a little too small for my screen. So hopefully you can see that your coordinate grids match up. The x-axis is time, the y-axis is water. So let's turn over to number 1 on page 176. And what I would like you to do is start working on number 1. You complete both the table and also complete the question here, where the equivalent ratio shown in the table. So complete those 2 parts, and also you can graph the information there for number 2 as well. So I want you to work on that now. So you can see the answers here. 6 to 12, 9 to 18, 21 to 42, 27 to 54. We can see the ratios that are written. 12 to 6, 18 to 9, 42 to 21, 54 to 27. And the reason why we would know that all these are equivalent, because if we simplify all of these, they would have the ratio of 2 to 1. And then also make sure with your graph that the x-axis matches up with the sulfur atoms and the y-axis matches up with oxygen atoms as well. So let's take a look at the essential question number 6. We'll go over this. It says, how do you represent real-world problems involving ratios and rates with tables and graphs? And we can see with this that find equivalent ratios and rates to make a table with different amounts of each quantity. Then use the table columns to make ordered pairs, graph the ordered pairs, and if it makes sense, connect the points with a line as well. So that would answer that essential question there on page 176. And this completes the video on ratios, rates, tables, and graphs. If you have any questions about this concept, please come and see me.